Okay, so in this question, they pretty much gave it away when they said you should factor the left side. As we can see, both sine x here is multiplied by 2 and multiplying cos, and there's a sine x here. That means I can factor a sine x out of both of these. And when I factor it out, I get sine x, 2 cos x plus 1. When you have a situation where something's multiplying each other and it's equal to 0, if either of these things is 0, you will get a 0. Because no matter what the other thing is, when it gets multiplied by 0, it becomes 0. That means this statement will be true when sine x is 0 or when 2 plus cos x is 0. At this point, our solutions are quite simple. We know that sine x is 0 from the sine curve at 0 degrees, 180 degrees, and 360 degrees. So there's three possible solutions for that. We also know that this one is solved by simple equation like that. And we know that this is a negative. And we know that cos x is negative in this category over here and this category, which means that my calculator is going to spit out this total principal angle the first time. And this is easily proven when you do it in degrees because we're so used to degrees. But if you look at the exact answers here, we can see that when cos is a half at pi over 3, pi over 3 is 60 degrees, I believe. Yeah, pi over 3. So we know that this is true when it's pi over 3, but pi over 3 is the acute angle. So the actual answer that we should expect here, if pi over 3 is the acute angle, would be pi minus pi over 3, which is 2 pi over 3. If I were to expand this, and I'm just going to show what I should expect from the calculator, 2 times pi divided by 3 is this, 2.09. So that means if I solve this, when is cos x equal to minus a half in my calculator, I should expect that number. So this is just to show what the calculator spits out. So I take the arc cos of this, make sure I'm in radians. And there we go. I get that number, 2.094. So let's just copy it down. Which means this whole principal angle here is this number in radians here. And then to figure out, as you figured out before, to figure out what this little acute angle is, which I technically already did, it's pi over 3. But if it wasn't an exact one that we knew, we would take pi, subtract that. That would be the acute angle. And then we would take pi and add that. So we would do this process. Take pi and we'd subtract that. We get 1.04. Then we would add that to pi. And we get this. And this should be the second angle. Right here. So these are the three situations where this is true. So in other words, this up here is true when x is 0 degrees, pi, which is halfway through, 2 pi, that's for the sine x, or when x is 2.094395, whatever, or 4.18879 radians. So those are 5 possible solutions. We can easily prove this by, we know that every time sine x is 0 pi or 2 pi, it's going to come out 0, and make this 0, and make that 0, and that'll add up to 0. So we know that's true. We just have to see if when cos here of this multiplied by the sine when that is that as well, plus when sine is that as well, times 2 by the way, will work out to 0. When we do that, we do 2 times, and I should have left it in memory, 2.0. Now my answer is not going to quite be 0 because I've rounded these numbers up. God damn it. I'm going to take this number And actually, I'm going to do what I did before. 2 times pi divided by 3. And I'm going to hit memory. Clear my memory and put it in memory. There we go. Now I have it in memory, which means 2 times this number in sine times this number in cosine plus sine of this number should be equal to 0. Is it? No, it isn't. So that means I made an error somewhere. So we try this again. Maybe we should just start with the cos of it. Cos of that. Oh, I hit sine, I think. Cos of that is, there we go, it's negative 0.5. Okay? Times sine of that is that. So we're going to hit equals. Then we're going to multiply by 2. So I get that plus the sine of that. There we go. Yeah, oh, that's what I'm not reading. I didn't look way to the right. To the negative 4.77, 4.7 is showing me that we're talking about almost 0. Yeah, so it couldn't quite get 0. So that answer is true. Then if I do it with this one here, I should put this one in the thing, and to do that I just subtract pi, change it to positive, add pi, so we're going to take the cos of that, just make sure it's in there. We're going to take the cos of that, multiply it by the sine of that, multiply that by 2, and then add that to the sine of that. Yeah, you see, they're total opposites. So again, almost a number that's 0. So that one works as well. So that means those 3 work. And the only reason it didn't work is because there's a rounding error that happens whenever you work with digits. And if we had it in pi's, for instance, technically, once I figured out it was pi over 3, really I could have kept it in pi's. We're talking about 2 pi over 3 and 4 pi over 3. So I think if I kept it in this format instead of using these numbers, it would come out as exactly 0. And I should just do one quick test of that to see if that's true. I'm going to try it with the 2 pi divided by 3. Now, I don't think it'll work because this is still a decimal that's in the calculator. I think I'd have to do it each time. So I'd have to take the sine of that, and add it to that. And then multiply that by the cos of that. Yeah, it's just too much of a pain to do it like this each time. I've pretty much proven it to myself. I don't have to prove it again. So that's how you do that. That one's relatively simple one, actually. I don't know why that's an extended thought. Your other questions were the 11, 12, and 13. So to do 13, we'd have to do the double angle formula, I think. So, sorry, this is an addition angle formula. So you'd have to pull up your addition angle rules. And for this one, you go to an image. Usually they're showing it in images. There we go. So you're using this first one. And that means wherever I see X, just put it in here. Wherever I see this, I just put it in here. Wherever I see this X, I just put it in here. And wherever I see this, I put it in here. We have to prove when this is equal to that. And there's a little trick here, actually, and this is where we go back to our, notice that this is sine of an angle is equal to the square root of 2. Well, there's a little trick there, I think. Because, let's see. No, there's not an exact value for sine square root of 2. Okay. I think what you were going to discover, though, is that square root of 2 ends up being divided by 2. So we'll see. And as I look carefully, I see cos of 45 degrees, pi over 4. And sine as well, pi over 4. And right here, we see it's the same value, square root of 2 over 2. That means I can replace with both of these with square root 2 over 2. Which means this is the same as this. And it's supposed to be equal to, I can put it on the left side now. It's supposed to be equal to square root of 2 for the first one full circle. Well, I can factor out this from both of them. And I'm going to end up with this in brackets and this outside the brackets. Then I can get rid of it by multiplying by the reciprocal. If you want step by step, I can multiply it by 2 and divide it by square root of 2. And I get this. Now, you might be puzzled by this. But it's, and actually, yeah, I don't think, you know what? Can that be equal to 2? Oh, 2 cos x, my bad. There we go. So it's like that now. There we go. I missed an important part. So we're left with that. And then you might say, oh, that's insolvable. But no, you can subtract 1 cos x from each side now. And you're left with when is sine x equal to cos x? Okay. Well, there's only one situation that I've explained to you before that these two are equal values, and that's at 45 degrees, where they both share the same adjacent and opposite are the same number. So if that's true, notice that they would both also have to come out as negative or both also come out with positive to be equal. So we have to ask ourselves, where will sine and cos both be positive with pi over 4? That'll be here in quadrant 1. Here sine's positive and cos is negative, so that's no. Here tangent is negative and sine is negative and cos is negative, so that's yes. And here cos is positive and sine's negative, so that's no. So in this quadrant they're both negative, which means they'll both be equal. In this quadrant they're both positive, so that will be equal. So in this first quadrant it's just pi over 4. And this second quadrant, it's pi plus pi over 4. And pi plus pi over 4 ends up being 5 pi over 4. So the two answers are here, pi over 4 and 5 pi over 4. And to prove that, you can always just go back to your original equation, and wherever you see x, substitute pi over 4. Okay. So pi over 4 over here becomes 2 pi over 4, pi over 2. So sine of 90 degrees, we know 90 degrees is up here, and that's a value of 1, so that comes out as 1. So we just simply have to do square root of 2 times cos of pi over 4 for this one. And that becomes 1. So 1 is equal to 1. You'll discover the same answer for the 5 pi over 4, because 5 pi over 4 plus a half becomes 7 pi over 4. Which is just short of over here. And you'll discover it works out to the negative version. They'll both come out as -1. Okay. So go ahead and do it if you want, but I know it's true. And then this is the only one we didn't do. These word puzzles are sometimes difficult, but I'd like you to solve it in the same way we did it with the 11, in that wherever the angle is, so you have to be able to identify. So the book makes a mistake. It should be putting this whole thing in a bracket. And this helps us identify the x transformations. Wherever you see the x transformation, just replace it with the letter A. And you'll notice that it's easy to spot because the x transformations will be after the word sign and before the plus. So that's an x transformation. So all I'll do is I'll take the same equation and I'll replace it with the letter A. I'll say let A equal this. That's something mathematician you should say. Let A equal this, which means we're replacing it temporarily with the letter A. And I'm just going to put it right there. There we go. And then we read the question. The height in meters of a nail in a water wheel. So this is a water wheel. It's water in water, and it's got paddles. And as the river races by, the water wheel spins. And it's modeled by this. Notice the amplitude is 4 up and down, but then it's raised by 2.5. So it's going to have a max height of 6.5 and a min height of below the water of negative 1.5. That would imply below the water, where t is time in seconds. So we can see that this thing has been converted to pi over 4, and it's originally pi over 2. So that would mean our normal period is this. To see what the transformation is, we have to multiply it by 4. So that's 8 pi, and divided by pi. Boom. So it's 8 seconds. It's spinning every 8 seconds. Where t is time. During that period of time, the nail is below the water in the first 24 seconds. During that period of time, is the nail below the water in the first 24 seconds that the wheel's rotating? Now, this is interesting because it takes 8 seconds to go around. It's going to be 24 seconds. We'll spin 3 times. So this is a good example of a question where they not only want you to find the first sine curve, but the second and the third. And to find the angles after the first one, you simply add 1 period. Well, 1 period here is 8 seconds. So whatever time we find for this is going to be 8 seconds added to it. I'll show you as an example. But keep in mind this amplitude has helped me a lot because I now know I'm talking about a sine curve. And if I want to find the axis, it's here at 2.5. That's always the axis, 2.5. And I know it's going to go 4 meters down and 4 meters up. Well, I know 4 meters down from 2.5 is negative 1.5. So it's going to go as low as here. And I also know it's going to go 4 up from 2.5, which is 6.5 up here, 6.5. And the question is, when is the nail below the water? Well, if this is my new sine curve, and I know it's 8 seconds, by the way, and by the way, it's pushed right to 1 by 1 second, I can tell that technically it's going to start 1 second over here, go up, going to go up as high as 6.5, and then down here, and then up, and down here, and up. And when they say first 24 seconds, the wheel spinning, they mean over here. But it won't matter. We can see that it's going to be occurring roughly between 6 and 8 seconds. No, actually 8's up here. Between about 6 and 7 seconds, it's going to be around beneath the water. That's what we can expect. That just helps me with expectations. But we still solve it. We just have to figure out, we have to go back and figure out when is technically below the water. Well, anytime it's a negative value, it's below the water. And we count the x-axis as that. So essentially we're saying, when is this equal to 0 or lower than 0? When is it lower than 0? We just set it to 0. So our first step is minus 2.5 on each side. This side, but negative now. Then we're going to divide negative 4 by both sides. Oh, by the way, let A equal the whole thing. Sorry, let A equal the whole transformation. Sorry if that confused you there. There we go. Then we derive both sides by minus 4. Well, the minus disappears. 2.5 over 4 is the same as 5 over 8. I don't really have a good No, so I'll just do 2.5 divided by 4. There we go. So I get, when is sine A equal to this? Well, we know that sine is positive in the first quadrant and the second quadrant. So the angle we're going to look for is this first acute one, and the other one's going to be pi minus this one. So we solve for A. We take A is equal to the arc sine of that, and we're going to have it in radians because our question is in pi's. So I take out my calculator, and I find the arc sine of that. Make sure I'm in radians. I am. I get this. Now I'm going to put this in memory, just so I don't have to pull it up again. So that means my angle is this many radians. Clear, it's since 1.5 is 90 degrees, this is about 45. It's a little before 45, because 45 is 0.707. It's about 42 degrees, which means my other angle is pi minus that. Which is this one. So that's my second angle. Now we reintroduce our transformation. We just use this is equal to this. We bring A back because that's what A is equal to. We multiply it by 4. So we're going to multiply it by 4. We're going to divide it by pi. And then we're going to add 1 to it to solve for time. And that will give me my first time. I'm going to pull this back. I'm going to multiply it by 4. Divided by pi. And then add 1 to it. So my first time should be this. So time 1 is this. And how many decimals? Doesn't really say. Let's try this. 1.8 seconds. Now, does that make sense? Yes, it does, because remember that our sine curve started 1 second to the right, which means in the first couple seconds over here, it was down below. All right, so that should be the first answer. The second answer will be the 2.46. We have to multiply the 2.46 by 4, then divide it by pi, then add 1. Subtract pi to get it back again. Get positive, so I have to multiply that by 4, divide it by pi, and add 1. And the second time says it's coming out of the water. We got a little bit of a problem here. There we go. This is technically the first time. So in the first 24 seconds, because I'm displaced to the right by 1, there's a little period right here where I'm under the water. Then this is the first time again. And so I have to find this time beyond. So it still works. It's a little bit annoying. And yeah, I think that's right. But to find the next time zone, might not be right. Might have to have figured out the time in the next one. But I'm going to try it anyway. I know that the period is 8 seconds. So it's this first time, this second time. And then I'm going to add 8 seconds each time. This first time. Yeah, I don't think this is going to be quite right. We'll see. This next time. And then I'm going to add 8 seconds to that last one. And 8 seconds to that last one. And so these should be it. Now, I might have made a calculation error because I'm very tired. But Desmos to the rescue. So just like this one, we're going to put in the... Oh, it's flipped. That's why it's got these times weird. Well, glad the calculations fixed it for me. So sine. And then in here, I see pi over 4. That's why we need brackets. And then it's my time, which I'm just calling x minus 1. And then we've raised it by 2.5. And then remember, there we go. Good. There we go. Now remember that it's for the first 24 seconds. And also remember that the thing has changed dramatically in terms of it goes down as far as -2, we'll say, and up as far as 5, 6, 8, yeah. And then we won't be able to see it clearly until we fix this from 0 to 24 seconds. We'll call it 25. There we go. And notice when I put those time restrictions on Desmos, it's going to tell me, only show me the graph that's under it. Now I'm going to set my y, my y is equal to 0. That's the x-axis, which is technically the water. And hopefully I'm going to see these times: 1.86, 4.14, 9.86, 12.14, 17.86, and 24.5. Let's see. 1.8, yeah, remember that I've rounded up. 4.14, is that right? Yep. And then 9.86, 12.4, and the reason I had my guesstimate wrong, because I forgot this negative here, flip my sign upside down. So it actually starts going down and then coming up. Doom, and up. This doesn't matter up here. This y is equal to 5. Just this x-axis does. So there you go. That's the answer to that.